Alright, this video is going to cover the Section 3.5 review for our Geometry Chapter 3 test coming up on Friday. The slopes of perpendicular lines are opposite reciprocals. Parallel lines have the same slopes. And the shortest distance from any point to a line is a perpendicular bisector. I feel like this came up in a section earlier than 3.5, but a perpendicular bisector. In the next two problems, numbered 9 and 10, write the equation of a line that passes through the given points and is parallel to the given line. So I have an x and a y, and lines that are parallel have the same slope. So the m I'm going to use in my new equation is going to be the same as this one, a half. I'm going to use my y equals mx plus b format to solve for what the b value is. I know in this line it hits the y-axis at -8, but my new line goes through this point, and I have to figure out where it hits the y-axis. This is going to give me -3/2 plus b. That's 1.5. I'm going to add 1.5 to both sides. And that's going to leave me with -4 plus 1.5 is going to leave me with -2.5 for my b value. That could be represented as -5/2. So my slope is 1/2, my b is -2.5. The equation of the line parallel to this one that passes through -3, -4 is y equals 1/2 x minus 2.5. In number 10, I noticed that I have an x and a y, but the equation that's given for the line it's parallel to isn't in slope-intercept form. So I'm going to solve it for y to put it into that y equals mx plus b form so I can see exactly what the slope is. So my first move was to subtract 2x's from both sides. Now I'm going to divide every piece of this equation by -6, so I'm in that form y equals -2/6 is going to reduce to 1/3 x, and 12 divided by 6 is going to give me -2. So right now I have a slope of 1/3 to write my equation for, and an x and y of 3 and 6. So I'm in the same place I was in where I started over here. I'm going to use my y value. 6 equals mx plus b. The x value was 3. The y value I had was y equals mx plus b was 6. 6 equals 1/3 of 3 is 1 plus b. If I subtract 1 from both sides, b is equal to 5. So the equation of the line that goes through 3, 6 and is parallel to this line is y equals 1/3 x plus 5. I'm going to move on to the perpendicular problems. These problems are numbered 11 and 12. This is the back page of your review packet. Perpendicular lines have slopes that are opposite reciprocals. So I'm going to grab in number 11, I'm going to notice I have an x and a y. I also am going to grab the slope of this line being -2. The slope of a line perpendicular to it is going to be its opposite reciprocal, which would be 1/2. So using my x and y and my opposite reciprocal of this slope, 1/2, I'm going to solve for the b value and write my equation. Y equals 1/2 times 4 plus the missing b. -2 equals 1/2 of 4 is 2 plus b. If I take 2 away from both sides, b is -4. So the equation of the line that's perpendicular to this one and going through 4, -2 is y equals 1/2 x minus 4. Now, in number 12 here, I'm in the same boat as I was on the other one. I don't see the slope in the way that this is set up. I'm going to solve this equation for y to find out what the slope of this line is. -6y equals 18. Now, maybe I'll put my -4x out front. -4x plus 18. I'm going to divide every piece of this equation by -6 to get y alone. Y is equal to, this is going to simplify to +2/3 x. Minus 18 divided by 6 is -3, so -3. The slope of this given line then is 2/3, so using my x and y and the opposite reciprocal of 2/3, which is -3/2, I'm going to do my work now to find the equation that has a slope of -3/2 and goes through the point 2, 3. So y equals mx plus b. 3 is equal to -3/2 times times 2 is going to give me negative 3 plus b. When I add 3 to both sides, I'm going to get my b is equal to 6. So the equation of a line that's perpendicular to this one and goes through 2, 3 is going to be negative 3/2 x plus 6. Now, in the next group of problems, I have to determine if the lines are parallel, perpendicular, or neither, which means I have to compare their slopes. Right here, I'm seeing the two slopes of 3 and negative 3. Those are opposite. They're not opposite reciprocals. These lines would be neither parallel or perpendicular. Neither. When I go into number 14, I can see that I'm not in slope-intercept form to figure out what the slopes are. So actually, I'm going to move over here to 15. I'm going to do that, and then I'm going to spread my work around and get 14 and 16 going. Same deal with 15 here. Neither of my equations are in slope-intercept form, so if I solve for y, I'll be able to examine what their slopes are, and that's what we need to compare to decide if they're parallel, perpendicular, or neither. So by taking 6x away from both sides, I'm getting into the y equals mx plus b form. I'm dividing everything by negative 12 to leave y alone. This is going to be a half x plus 2. Negative 6x divided by 12 is going to give me a half x. So in 15, this line has the slope of 1/2. What I need to do for the second equation, 3y, let me move it over here, 3y equals 2x plus 18. I just need to divide everything by 3 to get that out of there. Y equals 2/3 x plus 6. When I compare these slopes, a half and 2/3, I find that these slopes aren't the same, nor are they opposite reciprocals, so those lines are neither parallel or perpendicular. When I look at 14, I'm going to drop over here for 14. I've got to get these equations into y equals mx plus b. So my first one, let me put them both down over here. 4x plus 6y equals negative 48. I'm going to take 2 x's away from both sides. 3y equals negative 2x plus 15. I'm going to divide everything by 3. Y is equal to negative 2/3 x plus 5. The slope for this line is negative 2/3. Let me solve this equation for y. Take 4 x's away. 6y equals negative 4x minus 48. Divide everything by 6. Y equals, there's negative 2/3 x minus 8. They have the same slope. In 14, these lines are parallel. Both of them have the slope of negative 2/3. Last but not least, number 16. This is 4x plus 2y. I'm going to take 4 x's away from both sides. Focused on this equation right here, minus 4x. So 2y equals negative 4x plus 10. I'm going to divide every piece of this equation by 2. Y is negative 2x plus 5. Slope of this line is negative 2. Looking over here, the slope of this line is 1/2. I don't have to solve anything for 16. So negative 2 and 1/2, those are opposite reciprocals. These two lines are perpendicular to each other. Now, last but not least is looking for the equation of a line. And if I'm going to get the equation of a line, I need to find the rise over the run. I want to find the slope, and I also want to find the y-intercept of the line. From your friend's house to her school. Your friend's house is sitting at 5-0. And from her house to the school, I've got 2 pairs that I could, I'm going to have to add a piece of paper here, I think. I've got 2 ordered pairs that I'm going to start with in number 17 in order to write this equation. I have to write the equation of the line that's right here. And so I'm grabbing the points 7, 7, and 5, 0. Now, in order to write the equation from 2 points, I've got a couple parts that I have to do. I have to calculate this slope. Let's call this x1, y1, x2, y2. I'm going to do the difference in y, 0 minus 7 over the difference in x's, 5 minus 7. That's going to give me negative 7 over negative 2. That's positive 3/2. So the slope of the line is positive 3/2. Let me go and use a couple of points in order to find the y-intercept. So let me go use, not a couple, but I need to grab a point. I'm going to use this as my m, 3/2, and I'm going to pick up this point and set it into that y equals mx plus b again. and 0 equals 15 halves plus b. That's 7.5. I'm going to take away 7.5 from both sides. And I'm going to find out that that b is negative 15 halves, which is actually negative 7.5. So the equation of the line from your friend's house to school is y equals negative 7. Oops. The slope is 3 halves. Y equals 3 halves is 1.5. 1.5x minus 7.5. Now for 18, the equation of the line from the school to the library, I'm going to approach the school to the library just a little bit differently. I actually want to do the school to the library work right on my graph, because the way I see it here from the school to the library, its y-intercept is 0. The b value is 0, and the slope is actually up 1, right 1, up 1, right 1, up 1, right 1. The slope is 1. So for number 18, I think this is a pretty easy equation. It's y equals 1x plus 0, or just, 1 times x is just x, so I could actually write this as y equals x. Now last but not least, in number 19, we're looking for the distance from our friend's house to school, so this gets us back into using the distance formula. 19. Friend's house to school, I've got the points 5, 0, and 7, 7. It doesn't have anything to do with slope. It has to do with the length of the segment, the red segment. So x1, y1, x2, y2. I'm going to set up my distance formula naked and plug the numbers in. Difference in x is 7 minus 5, 7 minus 0. That's going to give me 2 squared plus 7 squared. That's going to give me, and I'm putting the radical sign over both, 4 plus 49 under the radical, and that's the square root of 53. Now in this case, because we are talking about how far something is, I'm going to go into my calculator and find out what the approximation for the square root of 53 is. Square root of 53 is about 7.3. So there we go. There's all the 3-5 review, including a little bit of distance.